Hello everyone and welcome to this next lecture. So it's almost 3 p.m. and I will get started very soon. So as before in the last lecture we had talked about list manipulations, and in this lecture I will get started with Python Numpy. So just before I get started with this lecture, a little question: does anyone have any doubts from the previous one? Well, in that case, I'll just get started. So let me go over to my Jupyter notebook and let me say, so this is where I stopped yesterday when I was importing Numpy as NP. Now, as before, as I said, Numpy is the name of a package. In order to import, I have to use the import keyword. That means I am importing another module. And the module in this case is called Numpy. Now, this second part is actually optional, but in almost every data science project, you will see this happening. That is, Numpy will be imported as NP. And that's what I'm doing here. So let me run this command again. Now, in yesterday's lecture, we saw that we can have lists. We created several lists, which are basically the equivalent of arrays in other programming languages like C, C++, Java. Now, and we saw that we can actually perform a lot of calculations with these lists, right? We can do mathematical computations, we can do several other things. We saw some of the inbuilt functions with Python, and we also saw that we can write our own functions as well. So now the question is, why do we need Numpy? The reason for that is pretty simple. When you have a lot of data, particularly when you're doing data science projects, you're working in machine learning or artificial intelligence, you will have a lot of data. So your arrays will no longer just be 10 or 20 elements. They may have millions of elements. They may have even billions, depending on the number of data that you're actually working with. So in that case, Python lists will not be good enough, right? Python list number one may actually end up being very slow to begin with. And over and above that, they may actually eventually cause memory issues and things like that. And that is the reason why when you have a lot of data, you should use Numpy. Okay, so to begin with, how do I start with the Numpy array? So let me just create some space here. Let's start. Simplest way to do this is, let's say we have a list, just like with yesterday. I just put some random numbers. So this is our list. Now, this list, which is an array, can be directly converted to a Numpy array in a similar way. So I can say array1 is equal to np array list1. That's it. So basically I am passing a Python list to the array function in Numpy, which converts this Python role, that is, which converts a Python list to a Numpy array. So let me run this command and let's see what we get. So if you look at this, we get something different. Before we just got a list, right, in square brackets. Now you see there is an array. This specifies it's a Numpy array. So let's go and look into it. Let's do type array1, and you see here it tells you that this is the kind of data it is. It is Numpy ND array, right? So there is, you can also look at array1 dot, and if I do tab, there is a method called dtype. Oh, sorry, I put another T at the end. Dtype. Dtype means what is the data type? And the data type here is integer 64-bit. Right? And this will change depending on the kind of data you have. If you have float, it will be float. If you have string, it will be string. It could be anything. Right? So again, I'll just pause for a minute and ask, does anyone have any doubts so far?
Hello, I didn't understand the difference between array and list here. Can you repeat that part again?
No, the thing is like this. The array and the list is a data type object with Python. This is raw Python, just basic Python. Numpy is an additional package. Okay, Numpy is an additional package, and this package maintains a separate class of data types called arrays. These are NumPy arrays. Now,
Okay.
as such, the data can be very much the same, but what is the difference is that NumPy arrays are now processed by NumPy. And any processing, which is what I will show you soon, is much faster on a NumPy array than it is on a Python list.
Okay.
I hope that answers the question.
Yeah, fine.
So now that actually it's a good question, I'll tell you why. So let's say, for example, let's look at some other examples of how we can create NumPy arrays. So for example, one other way of creating a NumPy array is just like in Python, there was the range object. Here there is an a range. All right. A range basically means array range. And you can look into the help of this. Again, exactly the same syntax as with the range function. There is a start, there is a stop, there is a step. All right. So, and now here it is very important to understand returns evenly spaced values within a given interval. Now, and I will show you the difference of this. The step here, as you will see, the default is 1. But if you come down and look, the step can also be a float. And I'll show you how that is now. So, supposing, for example, let's say simple case, NP a range 10. And if you look, you get a list of 10. This is just like saying list range 10. Exactly the same. Only thing is, just like the question was asked, this is a NumPy object as opposed to this being a basic Python list, which is a basic Python object. Now, let's go ahead and see what else you can do. There is also the option of specifying a start and a stop. So let's say I say 10, 11. I can say 0.5. That is possible. In Python list, it is not possible. In Python, the step has to be an integer. The start has to be an integer, the stop has to be an integer, and the step has to be an integer. But in the arange function, which is basically array range, the start, the stop, and the step need not be integers. By default, they will be integers, but you don't have to have them as integers. So let's look at what we get. And this is what we get. This is now an array where the number starts at 2, it stops before 11, but it increments at 0.5. So here I'll just stop and ask, does anyone have any doubts so far?
Yeah, Shiv Kumar, would you please repeat? You said that the increment step has to be an integer, right? And
in Python, basic Python range function.
Okay.
So like for example, let me say list range, and let me try the same thing again. Sorry, to 11.5. And you see, float object cannot be interpreted as an integer. It's saying that this step that you have given me is a float, but I am expecting an integer. So the range function will take only integers.
Okay.
But the arange function with NumPy will take floats as well.
Okay. Yeah.
Any other doubt?
Hello?
Yeah, go ahead.
Yeah, like you mentioned in lists, we can have a different data type objects. Does the same work with NumPy arrays?
Yeah, let's try it out. Apparently, and yes, it is okay. The only thing is, look at the data type now. The data type now has to be a general data type. See, before, if you note, you see it has converted all of them to string. See what it has happened?
Yeah.
We specified them as 0, 2.3 and high. So what it took was, it converted them all into one compatible data type. And it converted them all into string. Because there is no way you can express a string as a number. but you can express a number as a string. So Python said, okay, if you want to combine it, then I'll make everything a string. You figure out how to do it later.
All right. Okay. Thank you.
Yeah. Any other doubt? Okay, so I'll just show you a few other useful functions and then we'll start manipulating them. So far we were using the arange function and we passed an array. Now, supposing I want an array of all zeros. What do I do? For that, there is a zeros method. Okay, again, let me do shift tab. I would strongly recommend that get used to this thing of doing shift tab. Matter of fact, try this out. Try to do np, do tab, see what all you get and play around with this. This is a great way to actually learn a software just by playing around. Okay. So let me show you. This will give zero says shape, and I'll talk about shape very soon. If it gives you, if you give this function a shape and it gives you a type, it fills it with zeros, right? So let's look at how to do. Let's look at the simplest case. I want 10. I want an array of 10 elements. And this is what it has given. So now the question is, what is this shape? Now let's look at what this shape is. As I said before, like in lists, okay, a basic Python list, you can have multi-dimensional arrays as embedded lists. So for example, let me just give you an example of a simple list. Let's say I say 1, 2, 3, 4, 5, 6. Okay. So what I'm doing is I am inserting a list, two lists within a list. So this is an embedded list or it's a multi-dimensional array. So let's see what this looks like. So basically I am expressing a 2 by 2 array. That's what I've done using this. In Numpy, we can do the same. For example, I can say array5 is equal to np array list2. Like I said, you can pass any list into this array function and it will convert it into a Numpy array. So this is what it has done. And here it has nicely formatted it. So now you see it is, you can actually clearly see visually, it's like basically a 2 by 3 array, right? This is what we know. So now the question is, this can we extract what is the shape of the array? The answer is yes. There is an attribute called shape. So this shape tells you how many rows are there, how many columns are there, right? So here, I'll just pause again for a minute. Does anyone have any doubt?
Yeah. Hello.
Yeah, go ahead.
Yeah. So here, what we have is the two sub arrays have the same number of elements. What if that's not the case?
Okay, let's try it out. It won't allow it because unlike Python lists, a Python list is any collection of objects. A NumPy array expects there to be some kind of, what do you call, some kind of rule to it. But the best way to do is just to try it out. Now, you see what it has done? When you pass it in this manner, it sees automatically, like here it converted directly, it took a number. So it basically gives you a 2 by 2 array. But here you see, it sees that you have given it an incompatible object type, right? We have not specified a proper, what do you call, multi-dimensional array, because the second row doesn't have the same number of columns. So the result is now NumPy says, okay, I won't throw an error, but I am not going to give you the same kind of array because you created a mistake. So I'm going to cast them as lists and I'm going to insert them as separate Python lists. So this is what you get. So it won't throw an array, but this, if you try to use this in your computations, it won't work.
All right. Thank you.
Any other doubt? Okay, so I'll just show you now that we've talked about shape. Let's say we want such an array of zeros. So let me look array 7 NB zeros. Now we saw before that it had this argument called shape. So now let's say I pass this shape. Now the problem is it says shape. The reason why this didn't work is because there are 3 arguments: shape, the data type, and the order, right? Now, if you want to pass it, the shape, as an argument, you must specify it as a tuple. Now it will work. So important thing is here, when you write the shape, it is important that you put that separately as a Python tuple so that it sees it as just one argument. So now it has taken the shape and it has given you zeros in that aspect. So in the same way, I can create any kind of array. Let's say, for example, np.zeros 10, 15. And this will just work as well. So you can have even very large arrays in this way. So sometimes when you're like actually trying to do something like solving an equation or something else, you need a large array. This is one way to initialize your array, because you want in the beginning sometimes all your elements to be 0. So this is a good way to create such an array. So again, I'll just pause for a minute. Does anyone have any doubt? Okay, so I guess nothing is. So I'll continue. I'll just show you a couple of more useful methods which are used to create. Now, in engineering, quite often you'll see the use of the identity matrix, right? An identity matrix is basically a matrix with 1 on the diagonal and 0 everywhere else. So it's quite useful many times in engineering when we're solving equations. You need an identity matrix. Now, there is a way to create an identity matrix in Numpy. That is by using I. I means identity matrix. So again, let's look at the data type. Now, it's very important to understand an identity matrix by its definition is when it has ones on the diagonal and zeros everywhere else. So in this case, you will see that if you can specify just the number of rows, and it will give you a diagonal matrix, or rather a square matrix, which is purely diagonal. Or you could specify even a rectangular matrix and it will still give you ones on the diagonal. So let's try that out. So let's take I of 3 and let's check out this array. So this is a very simple array that we might have always seen whenever we did engineering. Identity matrix, 1 on the diagonal, zeros everywhere else. Now let's try the other one. Supposing I say np I and I say 3, 5. Oh, sorry, it's not a tuple, it's actually an argument. Okay, let's look at it again. These are separate arguments. So n is the number of rows, m is the number of columns, right? So it's important that you match the arguments of each and every function with the documentation. So, and here you see, we get a rectangular matrix, ones on the diagonals, zeros everyone else. Now, usually you may not see this, but if you need something like this, you can use this I function in such a manner. So again, I'll just pause for a couple of minutes. Does anyone have any doubts? Okay, nothing. So now that we've done with this, these are the basic methods of how we create an array. Now the next thing is, can you once have an array, can we manipulate the array? So yes, the answer is there are lots and lots of manipulation methods. So let's look into some of them. So again, let me just create another array, call it array 11, np arrange, and let me give it 24 elements. Okay. So array 11 is a numpy array which is just single dimensional from 0 to 23, so 24 elements. Now the first thing is, let's look at the shape. Shape is 24 comma 0. You see, when it says comma null, it means whatever is on the front is the number of rows. This is like what do you call it, a column matrix. Even though it appears in this manner, it's a column matrix. So now the question is, can we reshape it? There is something called reshape. See, there is reshape and there is resize. So let's look at this. Reshape means you can give it another shape and it will return an array containing the same data with the new shape, right? So you can see these are some examples. You just have to pass another shape. So now let's say, for example, we have 24 elements. So there's a couple of things we can do. For example, we can say 2 comma 12, and this is what we get. So it has broken up this one-dimensional array into a two-dimensional array, but this time there are 2 rows and 12 columns. And we can actually do this in several ways. You can do this in any way you want, or for that matter, we can even convert it to a row matrix. So this is actually a row matrix. We can actually do shape here, and it will say this is exactly the opposite of what we got before, because now it is a row matrix. So now the next question is, what if they are not compatible? So let's try that out. So let's put 6 into 3, and you see there is an error. The reason is simple. The data has to be compatible. You are reshaping an array. You are not deleting or adding elements to the array. So the data has to be compatible. So when you reshape, make sure that you are using all the data in your array. Right? So again, I'll take a little pause and I'll ask, does anyone have any doubt?
Is this reshape similar to transpose or no? Transpose
no.
of a matrix.
No, transpose, I'll talk about it soon. Transpose just switches the rows and the columns. That's it. So like for example, actually that will be, I'll talk about it very soon. But like for example, let's say I have a matrix. I'll just write a matrix. How do I write? I will just write array 12 is equal to np array. Let's take 1, 2, 3, 4, 5, 6. All right. Oh, sorry. I have to put this in a list because you're passing an embedded list. I cannot pass 2 lists like that. And let's say I have this. Okay. Now, array 12 dot transpose will just switch the array to the other aspect. So like for example, this is a function, suppose. So this is a function. So when you execute this function, you see it has merely made your row into columns and columns into rows. So that's all that the transpose does. The reshape, however, you can convert the data in your matrix into any other compatible form. So like for example, if you have 24, you can think about all the factors you can have. You can either make it from a simple column matrix to a row matrix, or you can convert it into 3 into 8, 8 into 3, 6 into 4, 2 into 12, whatever you want. So this is the advantage of reshape. Transpose is just changing the rows and columns.
Got it. Thank you.
Any other doubt? So I'll keep going for now. The next method is, now for example, we talked about, if you just scroll up, when we were talking about lists, we talked about how we can apply functions to lists, right? So like, for example, we could apply such a function to an array, right? Or a list. So there are ways in which you can apply, if you want, let's say, for example, let me come down and repeat that again while I scroll up. So let's say, for example, let's just take a list 3 is equal to range. We just put list range, and I'll put 3 to 7. Okay, so this is the list, and I'll just check what is list 3. This is what I get. Now, as I said before, supposing I want to take the square root of each element, right? Now, there are different ways to do it. For example, as I said, you can just import math. And after importing math, we can do a list comprehension. So for example, we can do something like math.sqrt x for x in list 3. Okay. This is something you can do. And you get the array. All I'm doing is taking the square root of each and every element. Now, it's important to understand, in raw Python lists, you must apply the function to every element on your own. You must write that loop. Either you have to write a for loop, or you can use the list comprehension, or we can use the math method. So you can also say list5 is equal to math.sqrt comma list3. This will also work. Same method, this will also work. So if I see the result, this will also work, right? Of course, I have to put a list. And if I do it now, it will work. So I get exactly the same result. But it's important to understand that in raw Python list, you must apply the function by yourself to every element. In Numpy, let me do this in Numpy. So let me just take this list and cast it as a Numpy list. So let me say array, where did I stop? I think at 12. Yeah, 12. So let me continue with 13. NP array list 3. Okay. And let me check what this array 13 is. It is this array. Now, supposing I want to do the same thing again. I want to take the square root of every element. Now, the question you'll ask is, can you do this? The answer is yes. You can loop through every element of a NumPy array just like you did with a Python list. But the best thing about, oh no, okay, I have to end it 10 minutes, that's what it's saying. But anyway, I will be ending soon. The best thing about NumPy is that you can apply a NumPy function to every element of a NumPy array just by using NumPy functions. So for example, we saw math.square-root. In the same way, there is something called np.square-root. So for example, if I say np.square-root of 3, this is what I get, exactly the same result. Okay. Now, the best part about this np.square-root is that not only can it take a number, it can take any argument, right? This argument can be anything. It can be an array, it can be a number, it can be anything. So let me show you what that is. If I say np.square-root array 13, it automatically applies this function to every element of the array. Automatically does it. You do not have to create a loop. It does it on its own, right? This is the best part about NumPy. So you do, when you have complex calculations that you want to perform on a large amount of data in an array, you do not have to write loops. You just can apply the function directly, right? So now at this point, I'll take a pause and ask a question. Does anyone have any doubts?
Yeah, in terms of you talk about time calculation, in the background of this square root function, for example, the same thing must be happening, right? So how does it actually become faster with larger data?
The reason is about how Python handles data versus how NumPy handles data. So for example, are you familiar with objects and memory allocation?
Yeah.
Okay, so like for example, like in C++ or Java or anything else, whenever you create an array, it allocates a certain amount of memory elements for that particular data type, right? That's how it works.
Yeah.
Now, in terms of Python and everything else, they have a certain way that when they allocate a certain amount of memory, they start at a certain memory location and they keep track of all the elements. The compiler takes care of it. Now, in Numpy, when you do allocation in such a way, the algorithms are so optimized that this calculation is applied to those memory elements much faster. And this is something, since I'm running out of time now, maybe I'll show you in the next lecture, but you can actually time yourself and you find that when you apply this function, right, to a large array, let's say with 10,000 elements, this numpy function is almost 10 times faster than a Python function. It's just the algorithm. The inbuilt algorithm is so optimized that it's that fast.
Okay, I see.
Any other question? So anyway, since there are no other questions, I think I'm almost running out of time because like I said, we have a 40-minute time limit. So I'll just leave it for, I'll just spend maybe a few minutes more in just doing a little bit of Q&A. If you have any doubts until then, please do ask. But for now, I'll be stopping this lecture. Now, the only thing is, unfortunately, tomorrow I cannot have this lecture because I'm living in Germany and here there is a rule that on Sundays, it has to be completely quiet. There is a term for it in Germany. It's called leise Sonntag. Apparently, you can't even run a washing machine or anything on a Sunday. So unfortunately, I can't do this lecture tomorrow. In Germany, the walls are quite thin. So what I speak, everyone can hear. So sorry, but tomorrow there won't be a lecture. I will continue the lecture on Monday. Now on Monday, I will continue a little more with some advanced Python NumPy functionalities because we started with this, but I'd like to do a little more examples. And we will then start with matplotlib. So I'll just start showing you how you can plot NumPy arrays and generate plots using matplotlib. So we'll generate some sine waves and cosine waves. So any doubt? I heard someone speak. No, I don't think so. Okay, so next things, as I said, on Monday, we will continue with NumPy. We will do plotting. After that, we will start with pandas. So the other thing I would like to show you is that there is a site called Kaggle. And I would suggest that go ahead and create an account on Kaggle. It's free. The best part about creating an account on Kaggle is you have access to several data sets. And we will be using some data sets from Kaggle for pandas and doing analysis. So I would suggest go ahead and register. There are several ways to register. It's completely free. And we will during this period of lockdown, look at several data sets from Kaggle. So there are several data sets, like for example, there are stock market data sets. There is things like currency conversion, many others with data. So you can actually do a lot of little assignments and puzzles and things like that. And this is what we'll do in the next, maybe it'll take maybe 1 or 2 more lectures for me to get there. But I would say in the meantime, please do create an account and register yourself. It doesn't take much time, and go ahead and look through some of them and look at some data sets. It's quite a nice site. So as before, I'll be winding up this lecture. So any other last doubts, please do add them right now. So in case there is nothing, then in that case, I will say goodbye and we will see on Monday again at 3 p.m. So I will upload this video tonight and tomorrow evening, I will send out the link for the Zoom meeting on Monday. So Thank you so much for coming. Goodbye and have a nice Sunday. See you next week.
Thank you.
Thank you. Bye.
Thank you so much, sir.
Thank you. Thank you, everyone.